Good afternoon, good morning. It's good to see you all here. My name is Natalia Zubenko and I'm a business development manager for GTT in charge of onshore development market. I would like also to introduce my colleague, Amaury Manger.
Hello, ladies and gentlemen. Thank you for attending our webinar. I'm Amaury Manger, a product line developer in GTT, and especially dealing with the onshore tanks. Together with Natalia, we are going to speak about how membrane technology can help into minimizing the environmental impact and the effect of high metal costs on the onshore tanks.
Before we start our webinar, please note that we also would like to hear from you. That's why we will arrange a 25 minutes Q&A session in the second part of our webinar, and now also we will launch a poll questions for you. So the webinar will be recorded and will be available on the demand. Now we are moving to our agendas. We will switch off our camera now and we'll put it back during the Q&A session. Okay. Today's topic is of particular interest for those of you who are looking for solutions to reduce environmental impact and also the cost. In our presentation, we will focus on differences between membrane and 9% nickel technology for these two major points. At the end of our presentation, we'll also share the status of the ongoing onshore tank projects. So let me first give you a brief overview of GTT. GTT is a technological expert in containment systems with cryogenic membranes used to transport and store liquefied gases. Nowadays, GTT has more than 55 years of experience in the LNG industry. It provides its technologies on board of more than 700 LNG carriers. Around 10 years ago, we started adapting our technology, the carriage of LNG as fuel. As of today, there are more than 60 LNG fueled ships with GTT technology. But today, we are going to speak about onshore tanks, which are using the same technology. Onshore GTT technology stands under the brand GST. This technology had been selected for 37 onshore storage tanks located all over the world. The oldest one, built in France in 1972, is still in operation for 40 years already. The GST concept is well-proven technology directly derived from Mark III LNG carrier design. Most of onshore tanks with membrane technology are designed for LNG, but the containment system is also suitable for the storage of some liquefied gases such as propane, butane, ethane, ethylene, argon, and also ammonia. Let's now dive in more details about GST technology. Our purpose here will be to present you the design philosophies on GST tanks. Here, we are comparing our GST philosophy to the main onshore tank storage competitor, 9% nickel technology. So on the left side, you can see membrane tank with explanations of its main functions. And on the right side, you can see the same for 9% nickel. In the middle between two tanks, you can see the function of each element of the system. Both technologies are recognized by the main international codes to be at the same level of safety, as both systems are considered as full containment, as they're able to contain any potential leakage in the concrete envelope and also to avoid any gas release into the atmosphere. But the way to achieve this function is not the same, and there are some important design philosophy differences. The main difference between both technologies is that membrane relies on separation of three functions: structural, insulation, and tightness, whereas 9% nickel uses different structure or components to achieve different functions. For example, the mechanical loads from the cryogenic liquid are handled differently by concrete structure on GST tanks and by self-standing internal metallic structure on 9% nickel tanks. The second example is that membrane tanks use so-called load-bearing insulation, which is made of polyurethane foam, so that the tightness barrier and the insulation do not have to handle the liquid pressure load. They just transmit the load to the concrete outer tank. And the last example is that both tanks have liquid and gas tightness barrier, but for membrane, tightness is guaranteed by the corrugated stainless steel of 1.2 millimeter thickness. This leads directly to my next point. What does membrane system consist of? Technology used for membrane land storage tanks is similar to Mark III system used for vessels, and it benefits of its very large return of experience. Actually, the components of the GST system provided by the same suppliers than used for vessels. On this slide, you can see the internal view of the tank with the containment system components on the bottom and on the walls. For onshore tank, the design is optimized with its patented innovative arrangement, which limits the number of components. With only two elements, triangular and rectangular, 95% of tank surface can be covered. The panels are the standard size, 1 by 3 meters, whatever the tank capacity. Thanks to the double network of orthogonal corrugations of the primary membrane, which behaves like bellows and allowing for free contractions and expansions, the thermal stress on the membrane is almost zero. Moreover, membrane system has no theoretical limit of capacity. Therefore, the design limitation will come from the civil outer tank, geotechnical and seismic data, but not from the membrane system. So the storage capacity for membrane tanks can go easily above 300,000 cubic meters. What do you think? Will there be any difference if we compare two technologies with the same footprint? Let's have a look at this slide. Here, you can see the example of arrangement differences for 220,000 cubic meters membrane tank and 200,000 cubic meters 9% nickel tank with the same tank dimensions. As you can see here, thanks to the ability to optimize the arrangement and thickness of the containment system, membrane tank stores about 10% more volume than 9% nickel tank. Is there any way to increase the storage capacity even more? Yes. To improve the net volume even more, one of the GTT innovation is the use of the sump pit for pumps. They are dedicated to perform more efficient pumping of LNG at the bottom of the tank by minimizing the residual liquid level. This is not possible for 9% nickel tanks, as the tank shrinkage due to cryogenic temperatures will cause problem at some location. From the graph on the right side, you can see the additional volume advantage. The x-axis represents the tank volume, and the y-axis shows the additional volume with the membrane tank. In red color, indicated the 100% available volume, where you can find actually this 10% detailed on the previous slide. With the sump well, the additional net volume will depend on the tank geometry and the type of the pump used. Depending on the pump's NPSH distance, represented here in blue color, the additional extra volume will be even bigger. So the available extra LNG volume can be between 8% to more than 25% if we compare two tanks with the same footprint. And actually, the smaller the tank capacity, the greater the net volume savings for the membrane tanks. Now I give the floor to Amaury, who will present you environmental assessment studies.
Thank you, Natalia. So in this second part of the presentation, I would like to talk about a recent study done to evaluate and compare the environmental impact of GST and a 9% nickel tank technology. Our starting point was a previous study done on CO2 emission 5 years ago. And knowing that environmental aspects are nowadays topic of interest due to stricter regulation, political and general will, the objective was to update and complete the picture with up-to-date tools and data. So to do so, we worked with an expert company on doing this type of assessment, which is RDC Environment. It's a Belgian company. So first, I will make a brief overview of the case study hypothesis we've selected, and also on the methodology used to realize this comparison. So to explain the case study, we can see a summary here. So we are considering a 220,000 cubic meter LNG tank, which is built in China, and it's having standard characteristics, boiler of lifetime, etc. is standard ones. Of course, both technology are considered with the same inside volume. So this study is covering the full life cycle of the product. So it means it's covering from raw material extraction, mining, ground extraction, etc. It's also including transportation and transformation of this material into components used inside of the tanks. It's including all energy, all consumable used during the tank construction. We also consider the commissioning operations. And then it's also including the end of life. It's means the dismounting aspects and up to the recycling process. So the idea is really to consider from cradle to grave of all involved material in the tank construction. Something important to note is that we defined a high recycling level. We did consider a 95% recycling of metallic parts after dismounting of the tank. We did consider this because dismounting will operate in 50 years' time. And we believe that great progress will be made at that time regarding the recycling level of metallic parts. We of course consider the entire tank, so including the external envelope of the tank, so that means the concrete parts, as well as the insulation and the inner tank barrier, of course, inner tank barrier. So to better understand the coming results, and as it has a large influence of the on the environmental footprint, let's focus on metal quantity used between both technology. So this is what is shown on this graph. We can see the metal masses repartition in between 9% nickel tanks and GST technology. It is split by metal type. Here you have the different metal types, and we can see that a global difference of 40% of metal it's observed. So which is already which is a high value. It's covering the external envelope and the inside barrier. If we focus, so external envelope is mainly so concrete part. It's mainly steel alloy and some carbon steel. If we focus on what is inside of the tank, so what is different in between both tank, so it means the 9% nickel plates, which is composing the primary barrier inside the 9% nickel tanks, And if we consider the stainless steel, which is a barrier for the membrane tanks, we have here a 75% difference of mass quantity, of metal quantity, sorry. So that's really something important and having influence on the environmental impact. So now that we had a look on the cases considered, let's have a look on the methodology used. So this study is evaluating the impact on 16 different indicators, not only CO2 emission, but much more than that. These indicators are defined by the Joint Research Center, which is an organization providing scientific advice and support to the European Union Commission. You can see them here. They are listed here. And they can be summed up in a global figure, which is called average world citizen equivalent unit. And you have here the ponderation factor used to sum up these different indicators. So it's having a global value and able to make a global comparison of the impacts. So now we had a look to the hypothesis of this study. Let's have a look to the results. So we have here an overall view of the results. So it's expressed in average world citizen unit, the global figure I just present you, how it's put. And we can see a global difference of minus 23% of impact in between 9% nickel tank, which is here, and GST technology, which is here. We can see that there is different on mainly three aspects, which is climate change, fossil resource use, and acidification factor. They are the main difference in between both. So we are going to make a zoom in on these three elements in the coming slides. So let's have a look to the first one, climate change. The climate change indicator, it's a CO2 emission equivalent unit. In fact, so it's CO2 emissions. It's split here in the different sources of emissions. You have the construction and energy emission sources, commissioning also, all the transportation of different elements, material fabrication is a source of emission also, and it's also including the end of life contribution. But as it is recycling process, it's counted as negative value. And we present results with the global total is making the sum of positive emission and recycling process, which is in negative. So summing positive and negative, we have the global value. And we can see that comparing both total, we have 16% difference in between 9% nickel tank and GST. And these 16% difference are mainly coming from, we can see a in-tank metal part, where we have 62% difference of emission in between both. And it's directly linked to what I just mentioned before, the mass of metal difference in between both. So to remember, there is 75% difference of masses of metal inside of the tank. So let's have a look to the second main factor, which is fossil resource used. It represents the oil or any other fossil energy used to produce, transport, and assemble the tank. So we still can see the concrete part here, but it's similar for both tanks. What we can observe is that we have an increase from 9% to, or we have an increase for the GST technology regarding the material for insulation. It's 1.5 times higher, and it's coming from that we are using polyurethane foam, panels, which are mainly fabricated from fossil resources. So this explains why we have this increase. But on the opposite, and to compensate, we have less metal involved, which here is resulting in a reduction of minus 64% of using fossil resources. So the global overview of this indicator is minus 11% in favor of the GST technology. And if we have a look on the third one, main parameter, it's acidification. So we are talking here of acidification on air and water. It's mainly dealing with the sulfur oxide emissions. We can observe here a very important emission, and it's coming from the in-tank metal. So it's mainly linked here with the 9% nickel plate production, which is emitting a large quantity of sulfur oxide. Even if we did consider a high recycling level, where we can see here the effect of the recycling, the overall picture is 3 times less for the GST tanks. So minus 67% in between both technology. So this is also a large influence. So let's make a short recap of what we said about the environmental impact. So GST technology, global impact is evaluated at minus 23% compared to the 9% nickel tank solution. And this comes from a significant difference in metallic structure quantity in between both solutions. Now that we had a look on the environmental aspects, we will turn to another subject and move on to the cost aspects. This is generally an important topic addressed in the investment decision for LNG onshore tanks. But do you have any idea of what are the consequences of the recent metal price increase on the land storage tank solutions cost? So this is what we propose to have a look on the coming slides. So we can observe here the marketplace prices of the steel, so in dark blue, and the nickel prices. So we have the 5 last year market prices. So we did select the Chinese prices for the steel, and as there is no Chinese prices for nickel, we did consider the world one, the global value one. We have here on the x-axis the prices of the two of them, and we can see that since 2021, price have increased quite significantly. Yeah, the idea was to have a look on what are these influence, and mainly from nickel, which is price is already very high. Nickel prices have started increasing quite a lot beginning of this year, beginning of 2022. So here for this analysis, we consider the February average price, which was about $20,000 per ton. It's important to note that it has been a very important surge of this price since then, because in March, the average prices is now something like $32,000 per ton. So it's around here. But here we did consider the February average prices. So based on these raw material prices, we estimate what is the nickel 9% nickel prices, as it's not on the open market, and we can see that it's have largely evaluated and largely increased since last 2 years to reach value of around $5,000 per ton. So it's representing an increase of 70% in 2 years, which is really important. So considering this, let's have a look to how tanks price are impacted. So this is what we can see on this graphic. We can see in blue the price evolution of the GST technology, and in orange the 9% nickel price evolution. So we here consider a reference price. So we consider that both are at the same price in March 2020. So yeah, it's a proposition. Even if we believe we were already competitive at that time, we did consider price were equivalent to see how it's evaluating. We can see that GST technology have increased of about 2% of the prices due to the metal price increase. But on the same period, we can see that 9% nickel tank have increased of 12% of the total price of the tank. So it's making a difference of 10% in 2 years' time. So that's something important. So the global learning of this is that GST technology is less impacted by metal price evolution. And over the last 2 years' time, the competitiveness have evaluated in favor of GST of 10% of the total tank price. And so this is directly to the mass quantity involved in both of the solution, as we are using less metal than 9% nickel tanks. So this part is now finished. So over to you, Natalia.
Thank you, Marie. I think it was very insightful. Before we go to the next discussion about the ongoing projects, I would like to remind you that you can write down your questions already now in the Q&A's dedicated chart. So like this, we will be able to answer them after the presentation. So now let's have a look at the latest projects that we are performing now in GTT with membrane technology. At this time, there are 12 onshore tanks with the membrane technology under construction. But today we are going to speak only about 3 projects, 2 in China and 1 in Russia. So the first project that we are going to speak is Yanjin regasification terminal in China for Beijing gas. In total, there will be 10 tanks built in 3 phases. So the first phase consists of 2 9% nickel tanks and 2 membrane tanks. The footprint for all these 4 tanks is the same. However, the storage capacity is different. 220,000 cubic meters for membrane and 200,000 cubic meters for 9% nickel tanks. This confirms that I mentioned earlier that for the same footprint, membrane offered 10% more volume. Thanks to this important advantage and also to the significant environmental improvement with membrane tanks, Beijing Gas decided to equip other 6 tanks for phase 2 and 3 with the membrane technology. Here you can see the importance of this project for Chinese market, as it consists of not only 10 LNG tanks, but also the jetty able to load and unload the big capacity LNG carriers, and also the export pipeline inside China. Here we wanted to present you the project timeline. So our relationship with Beijing Gas started in 2019 when we first signed a cooperation agreement with Beijing Gas mother company BOG. The fruits of this cooperation grown into the partnership and the contract signature for 8 membranes. Here on this slide, you can see some of the main events of this project. And also what is very interesting to see is on your right side, on the bottom, there is a picture of all these tanks under construction. This picture had been done in December 2021, so quite a long time ago. And you can see already at that time, all 10 tanks are constructed at the same time. And on the back of this picture, you can see 4 tanks, and as you can see, they are all the same footprint. So the difference is not outside, but inside. So on the next slide, you can see some photos of this of the first membrane tank, this project. As you can see, the installation is going pretty well. On the pictures, you can see the main events such as moisture barrier application and the insulation panels installation. Currently, we are continuing installation of the panels on the walls of the tank. And actually, the delivery of the first membrane tank is planned for November of this year, which gives us only 7 months to go. And the second membrane tank now finished its hydro test and preparing now for marking out and insulation panels installation. The phases 2 and 3 of these projects, which are tanks from 5 to 10, they are also under concrete pouring phase now, and they will be completed in the middle of 2024. The second GTT onshore tank project in China is a 29,000 cubic meters LNG peak shaving emergency storage in Tianjin city, which is located 160 kilometers from Beijing. The membrane installation is already finished for this tank, and the final test ongoing currently. The delivery of this tank planned for July of this year, which is only 3 months to go. On this slide, we just wanted to show some pictures of the main events of this project, like roof raising, the moisture barrier application, and the hydro test. And the next slide shows you some picture from internal of the tank, where you have the installation of the panels on the walls and completion of the primary barrier. So it's pretty impressive. The last project that we wanted to present you is Arctic LNG 2 project. It's Novatek's second LNG project located opposite Sabeta, west of Gidan Peninsula. Unlike Yamal LNG built on permafrost, these 3 gravity-based structures will be sunk in the shallow water to serve as a foundation for the liquefaction train platforms. They will be equipped with LNG storage tanks of 290,000 cubic meters each, and 2 of the GBSs will be also equipped with a small ethane tank. The GBSs are built in the new Novatek's factory in Murmansk. On this magnificent picture, you can see one of LNG tanks of GBS-1. Impressive, isn't it? The work on GBS-1 is almost finished, and it will be towed away to the final location in Gidan already this summer. The work on GBS-2 is also advancing with the ongoing moisture barrier application. On the next slide, we just wanted to show you some photo from the construction side. Here you can see the installation of the insulation panels and the membrane well. Here, now I give the floor back to Amaury, who will present the future ready tanks.
Thank you. So we are now approaching to the end of this presentation, but before finishing, let's focus on what could be the future of GST. And so mainly in view of decarbonation, ammonia could be one of the solutions. So this slide is to sum up what is GST ammonia compatibility status. So to say that ammonia compatibility is on a good way for GST. So it's recognized that the stainless steel barrier we are using, it's compatible with LNG and ammonia, whereas 9% nickel still is not. So it means that we could be able to store in the same in a GST tank LNG and ammonia. But to do so, there are some adaptation to so tank structure have to be reinforced in regard of the ammonia density. We propose also to set up reinforced tightness testing procedures to be realized either at construction stage or retrofit stage, in order to guarantee that the no ammonia will go into the installation. And finally, that additional compatibility tests are ongoing. And so if we sum up the status of this compatibility, we can say that it's on a very good way, but there are still some checks ongoing to confirm it. So we are now moving to the conclusion of this presentation, and let's have a recap of the main messages. So GST enabled to store at least 10% more LNG in the same footprint thanks to a thinner insulation. GST onshore technology offer higher maximum capacities. It's the most eco-friendly solution with a reduction of 23% on the environmental impact. It is less dependent to raw material prices such as metal and nickel prices evolution, and the ammonia compatibility shall be available, and a testing campaign shall soon conclude on that. So to conclude, let's say that GST is the most sustainable LNG tank storage system.
Okay, now we're finished with the first part of our webinar. Thank you very much for your attention. We hope that you find it interesting and useful for you. Now we go to the second part of our webinar with the Q&A session. And before we start answering your question, we would like to hear from you. We'll launch a poll. We have only 3 questions to ask you. We would like to hear your opinion, and we will discuss it at the end, the results. So Amaury, can you please launch?
Yes,
poll?
so it should be on now.
Okay. Please go on with your answers. In the meantime, we'll have a look on the questions. So, Amaury, I see there is quite a lot of questions already here. I think I can start ask all these questions. The first one that I see, what is your prediction for material prices, in particular for metal in near future? Oh, Marie, I really hope that you have now the crystal ball and can answer this question.
Well, unfortunately, I don't have any crystal ball, so yeah, I'm not sure I will be able to fully answer that question. Well, even so, we've looked to metal price predictions. It's available on the market, and we saw that announcing some price reduction from the actual one, but not very significant reductions. So we can imagine that price will stay quite high. Well, however, yeah, as I was saying, yeah, I don't have any crystal ball, I cannot say, but maybe something about that. So the idea is not to say that prices are going to go up and competitiveness will continue being increasing for the membrane. The idea is to say that GST technology is really less sensitive to this price evolution due to less metal quantity involved. That is a key point to recall.
Okay, thanks a lot. So we have next questions. Okay, I have 2 questions which are quite similar. I propose that we combine them. So what is the typical timeline to complete the onshore tank? And how is the erection duration of the tanks with the same footprint and volume compared to 9% nickel and GST technology? So I just can give you an example of what had been done in China. So as we mentioned, that there are actually for the phase one, there are both technology are built with the same footprint, but with different capacity in the end. And then, as you know, the construction of this project actually arrived in a very difficult moment for everybody with the COVID situation. And then even though with some perturbation due to COVID, the duration of linked to the membrane construction was around 11 months. So there is, they're quite the same direction at that point, because in China, they're trying to advance the tanks at the same speed. So in general, for this type of the size of the tank, we can say that in 11 months, it can be done. So, and then if you compare different sizes, so it will be different. So the smaller size of the tank means fast it could be. But after it all depends on how many workforce you're going to put in the construction. But it could be quite fast, and we can find a lot of advantages in the construction with membrane.
Okay, thanks. I can see another question about LH2. So can GST technology can be used for LH2 storage? So now on, the existing technology is not designed for liquid hydrogen. So for instance, it's not possible. But there are studies going on where we are looking to that subject. But okay, the actual status is it's not compatible.
Okay, thanks a lot. Okay, the next question is, considering that GST tank can be about 10% small in size to have same capacity, what is the reduction in quantities of concrete, and why is the impact on of this reduced concrete relatively small in the environmental assessment? I think it's for you, Amory.
Well, in fact, we saw in the result that the concrete aspects was rather similar in between both. It's right that there is a difference in quantity, but not so important. So 10% to, but in our comparison, so the inner tank volume was the same. So it means that 9% nickel tank is a little bit bigger to have the same internal volume. This is why we could see that a small increase of concrete part for the 9% nickel tank, but it doesn't have much influence on the global picture. Really, the main aspect is the difference of mass of metal quantity in between both. Even though concrete is impacting the environmental aspect, it's similar for both.
Okay. Would you mind to read the next question?
Yeah, it's a cooling down rate of a warm empty tank higher for GST in comparison to 9% nickel one. So yeah, maybe you can answer if you.
Go ahead.
Okay, okay, I can do it. So cooling down rate is different in between 9% nickel tank and GST technology. We are less sensitive to contraction, thermal contraction, in part mainly due to the primary membrane, which is not is contracting but not moving globally. So we can have higher cooling down rate for GST than for 9% nickel tanks. Yeah, so this is an advantage, but cooling down is not very often in tank operations, but it's much faster for GST. I don't know if you have any idea of time, Natalia. I don't
I just
remember.
can give an example. For example, on the LNG carriers of the standard size of 174,000 cubic meters, the cooling down is done for all 4 tanks is in 10 hours. So you can see the order of magnitude, which is quite big. So in the first hour, you have the first 2 hours, you have the reduction of minus 40 degrees per hour with membrane tanks, which is much faster than with 9% nickel tanks, where you cannot go above 10 degrees per hour.
So,
okay, there is a next question. What is the duration from award to commissioning for about 50,000 cubic meters tank? So I was just trying to find out some internal documents of the construction of the 50,000 cubic meters, just to give an example. So what I see that from the moment that we receive the concrete, which is done, and we start with the moisture barrier application and other steps of the construction, so until the mechanical completion of the tank, we will need about 3.5 months to perform all installations of membrane. Then, of course, you would need to add some commissioning on top of it, like drying, cooling down. So let's say for 4.5 months, you can be able to finish the part which is concerned the membrane. So then you will need to add the concrete part, the construction of the concrete, which is about like, I'm not sure how many months is it, but I mean, we're not a civil designer, but we need to add some months for the concrete part. Okay, I see the next question. What is the grades when you mention steel alloys? So Amari, it's for you.
Okay, so it's the steel alloy mentioned in the presentation. So maybe I can come back to the slide. It's the one involved in the concrete part. So we can say it's standard steel alloy really. It's not as cheap as there is different grade. Let's have a look. So this one. So here steel alloy are corresponding to the one involved in the rim, in the stressing, in the pre-stressing or post-stressing of the concrete part. So it's not, it's standard steel alloy.
Okay, thank you. I think the next question is also related to the steel grade. Is only carbon steel and stainless steel used for onshore storage tank mark technology, or NO96 technology also can be used for onshore storage?
For onshore storage, we only proposing the GST technology, which is using stainless steel membrane. We would not proposing any solution nowadays with an Invartec solution technology, which is coming from the NO96 technology. So it's only solution we propose here is the stainless steel for the barrier.
Okay, thank you. Okay, next question is about the boil off rate. If the thickness of insulation panels is increased, can the GST boil off rate be further reduced compared with 0.05%?
That's a good question. Yeah. So a comparison we've made here was with the same boil off rate, of course, same performance of the tank. And so yeah, you see that insulation thickness is different. However, we can increase the thickness of the insulation we propose. So we can reduce, if requested, the boil off rate. That's a possibility, depending to the specification requested. So that's a possibility, yes, we can have.
Okay.
But,
I can just give another example on some recent project. So for 220,000 cubic meters, we can go up to 0.04%, for example, with the standard insulation panels of 400 millimeters. So basically, the bigger the tank, the easier it could be to go even below 0.05% above.
Mm. Yeah.
Okay, I have another question here. What is the maximum tank capacity that can be achieved on the membrane tanks? So as I said in the beginning of the presentation, that there is no limitation on the tank capacity for the membrane tanks. And we like to compare membrane with a Lego, because in a Lego you have all the standard components, and with the standard components you're able to build wherever you want. So kind of the same with membrane. So we build wherever we want the shape and the size of the tanks. However, there will be some limitations, but they will come from the civil design, in particular from the concrete dome roof, which cannot be built economically beyond of 100-meter diameter. But as for membrane, it can be easily go above 300,000 kilograms. So I think it was our last question. So Marie proposed that we now look at the replies on poll.
Yes, so let me find this.
Very interesting results, I see.
So I'm publishing the results, so you should be able to see them now. Can you see them or not?
Yes.
Yeah. Okay. So first question was, in your opinion, what's the main factor for onshore tank technology selection? And so answer was opposing answer was low price, overall lead time, environmental footprint, smooth permitting, and EPC guarantees. So we can see the first answer is low price. We can understand that. Yes. The second one, which is not so far, is the environmental footprint. So yeah, good to see that it's something of interest. And the third one, third position one, it's the overall lead time. So it's that's the main 3 point going out. Interesting result to see that environmental it's so high in the results. Second question was the world LNG storage capacity is increasing by almost 6% per year. From your perspective, what will be the most favorable way of storing LNG? So 3 proposition was onshore storage, near shore storage, such as GBS, and floating storage, was the third proposition, so such as FSU or FSRU. First proposition you put the head was is onshore storage, so it's our today topics. Good to see that it's still in a good position. And the second one is floating storage. Interesting to see that the nearshore storage is only with 8% of the answer from the actual audience. So okay, so that onshore storage are still the preferred solution. And if we have a look to the third question, it was, do you see any interest in NH3 or ammonia compatibility for LNG onshore tanks? The three proposition was no, yes, it's a nice to have, or yes, it's a must have. And the weekly can clearly see that the answer here from the audience is yes, it's a nice to have. Interesting to see. So ammonia compatibility is have interest, but it's not yeah, it's not a must-have. Okay, so interesting to see that.
It will come, maybe it will come a couple of years.
Yeah, I can understand that this is what is behind. People maybe it can it's one of the possible solutions, so it's good to be prepared. But for now, one is not a good solution. Okay.
Okay, so I think now we approach the end of our webinar. Thank you very much again for your attention and being here with us. You can see here we put our coordinates, our mail address and website. So please don't hesitate to ask more questions to us and to approach us for your future projects. We'll be happy to discuss it further with you. So thank you very much and have a good day. Bye-bye.
Thank you. Bye.